Welcome back everyone. In the last video we had discussed about multi-threading and GIL in Python. In today's video we will discuss about multiprocessing in Python. We can use multiprocessing whenever we need to run our program faster. Basically, if you need to run multiple tasks parallelly to run the program faster, then we can use multiprocessing. In today's video we will discuss about what is multiprocessing, when should we use multiprocessing, how we can implement multiprocessing. So let's look into the details. So what is multiprocessing? In definition, multiprocessing is the ability of the system to run more than one process in parallel. Let's imagine that we have 3 tasks to do in a program. In a traditional single programming system, it will process the task one by one using the single CPU core and memory. In multiprocessing, we can create 3 processes for these tasks and run them independently and parallelly so that we can reduce the total execution time. So using Python's multiprocessing module, we can create multiple processes and can run them parallelly. So rather than running a big task with a single process, we can create multiple processes and share the task for each process and run them parallelly to speed up the program. Let's take a simple Python example to demonstrate multiprocessing. So first we can check without multiprocessing. So here we have our 2 functions, our task1 and our task2. Both of these functions doesn't have much functionality, just a sleep method to add a 2-second delay, and also have some print statement. Also we added the start time and end time to calculate the total time to execute both of these functions. So let's check the script. So as you can see, it take almost 4 seconds to complete both of these functions to execute. Now we can add multiprocessing to this script to speed up the execution. To add multiprocessing, we need to import the library multiprocessing. Here we are going to create 2 processes using task1 and task2. To create a process, we need to add multiprocessing.process. So here is an argument called target where we can pass our function. So we created 2 processes. To start the process, we can use process.start. This will start the process. Process.join is used to wait the main program to complete both of these processes. So process.join will ensure that the execution or the main process will continue only after completing the 2 processes. So let's run this script. So as you can see, it took around 2 seconds to complete. So before multiprocessing, it took 4 seconds. So using multiprocessing, it took 2 seconds, which is a better performance. We can also use process pool executor to implement multiprocessing. For that, we need to import concurrent.features. Here, using the context manager with, we added process pool executor. We also specify the maximum workers as argument. Maximum worker means number of processes that we need to run parallelly. Executor.submit will submit the function to the process and run the process. Future.result is used to get the results from the completed process. The advantage of process pool executor is it's very easy to use. You don't need to manually add start and join methods to add the process. Using the context manager with, resource will be properly managed and it ensures proper cleanup of resources. Also, we can provide the number of workers that we need to run parallelly. Here we have another example that uses multiprocessing. In this script, we use a function called compute factorial, which basically returns the factorial of a given number. In the main function, I have created a list of numbers that I need to get factorial for each numbers. I added higher numbers because it's definitely takes some time to computation and it is also a CPU bound task. Here, I added number of process is equal to 4. We can change this number according to our CPU configuration. Increasing the number of processes doesn't mean that you will get more performance. It also depends on your CPU and memory that is available. So you have to adjust the number of processes based on the number of CPU cores available. Inside this process pool executor, we iterate through the numbers and create process. Basically 4 processes at a time. We can get the result of each process from the future.result. We also calculating the total time taken to complete the process. Here is the same code that without multiprocessing, basically sequential execution. Let's check the time taking for the sequential execution. It's taking around 28 seconds to complete. And if we run the code with multiprocessing, it will complete within 17 seconds, which is significantly better performance. So this way, using multiprocessing, we can improve performance for CPU-bound tasks. When should we use multiprocessing? People always have confusion with multiprocessing and multi-threading, and also have doubts like when should we use multi-threading and when should we use multiprocessing. First of all, we should understand the concept of multiprocessing and multi-threading. Selecting between multiprocessing and multi-threading depends on the requirement. If your task or the program is CPU-bound task, then you can select multiprocessing. And if the task is input-output bound task, then we can select multi-threading. CPU-bound task means task which requires significant computation and processing power. CPU is fully utilized most of the time during the execution of the task. So they spend most of their time performing calculations or processing data in memory. Examples of CPU-bound tasks are mathematical computation, data processing like image processing, video encoding, also like machine learning model training. Input-output bound task is one where the speed of the execution is limited by the system's input-output operations. These tasks spend a significant amount of time waiting for data to be read or write from or to storage or network devices. These tasks have very low CPU usage. Examples: reading or writing large files to the disk, downloading or uploading files over the internet, fetching large datasets from database, or application waiting for user interactions. So, if your task is input-output bound task, you can choose multi-threading. And if it is CPU bound task, then we can select multiprocessing. I hope you got a better understanding about multiprocessing and how we can implement to improve performance and speed up the program. So that's all about today's video. I will post more advanced topics like subprocess, decorators and meta classes in my future videos. So please support my channel. Thank you for watching and see you in the next video.